Hello, everyone. I'm super happy to be here today with Serg Masís. We're on Let's Talk AI, and I'm super excited for this episode. I've been waiting for a while because I have some crazy questions. I know some of you guys told me questions to ask Serge. So, Serge, first of all, how are you doing?
I'm fine. I'm doing great. Thank you.
Awesome. I always like to ask in the podcast for the guests to present themselves in a few sentences. It can be either fully professionally or who the person is. Could you introduce yourself to me and to the audience?
Well, I'm a lead data scientist in agriculture, a big agriculture company, and I like to. I work in AI, and I love to talk about AI, more specifically machine learning. Yeah, before that, I had a long career in web development, all sorts of things actually, not just web development. Um, 3D modeling, web marketing. I even owned a bubble tea shop. It's a long story. But
Hmm.
yeah, I'm just a very curious person, and I like to get my hands dirty with a lot of
Okay.
different things.
Awesome. Awesome. You mentioned that you didn't start right away with data science. You've done a lot of things. So I want to get back on that right away. But just before, I would like to ask you, what are you trying to achieve today?
Today,
I
man,
mean, not like today, but I know it's a tough question, but I always like
yeah.
to know because you have this whole career and maybe some people know you for specific things, but what are your goals today?
Well, my goal, I guess, is to just keep learning. I'm always interested in learning new things. And as I'm learning, I'm also teaching other people, which is kind of cool too. So the
Hmm.
stuff I've already kind of learned enough to teach, I'm teaching. So I guess that wasn't like a goal like several years ago, but I
Hmm.
realized in my prior career in web development, I was a team leader and mentor, and so it was a lot of what I did in
Hmm.
my job. So
Hmm.
I I still, I guess, I do that in one way or another through my books. I occasionally do like sessions with people that reach out to me,
Hmm.
and I also teach them stuff. So it's very gratifying. I don't think there's like this long term goal. I want to be like
Mm-hmm.
this or that. I
Mm-hmm.
just want to continue growing and evolving. I have
Mm.
a growth mindset, and my I guess my goals are more like short term and medium term. They're not so long
Mm-hmm.
term
Mm-hmm. Like
at the
improve
moment.
every day and just focus
Yeah.
on the process and not the end destination. And do you prefer teaching or learning, or is it a balance of both?
It's a balance. I prefer learning, but because I mean I can't do one without the other. But
Yes. Yeah.
um, yeah, it is gratifying to master something and then pass it on. I
Hmm.
think.
This is a great introduction because after later in the podcast, we're going to talk about the book you're writing. That is going to be the continuation of a book that is already published. Um, so, so I'm super excited to know your approach about learning, about teaching, and about a lot of topics. I want to deep dive with you into like specific use cases of machine learning, just to have some insights of like what framework do you use to approach problems and how do you approach them. Um, but let's start from, let's say, the beginning. So you mentioned that you had quite a journey,
Yeah.
a professional journey. What made you? What led you into data science and machine learning?
Oh well, I was already always interested in computers.
Mm-hmm.
Um, I didn't see it then. I just saw it as a tool where I could solve problems creatively. So I got into programming because of that. Then I discovered, you know, through my parents, I discovered, more boring applications other than, games and things like that, such as spreadsheets
Mm.
and databases.
Mm.
Um, and at the time, they were very boring because they weren't used to store a lot of information. You couldn't. You just couldn't. There were like all kinds of limitations, and their interface was horrendous. I mean, I'm talking like like monochrome screens with just like boxy little lines, and you know, you could only put so many different characters in a cell, and it took forever to make a spreadsheet. But
Mm.
I started to see some potential that I started to use spreadsheets
Mm.
back then, as a teenager, and then as I grew older, I kind of saw it as like a utility, not something I could derive a lot of creative value from, because there
Mhm.
was, the potential was there, but you just couldn't store enough. You couldn't store enough variety of information in so many different ways as you can now. So I got focused on the internet because of that, because it was this untapped source of knowledge
Mhm.
and everything. But it wasn't until I started working in web development, and then I started to work for these sites that would just accumulate tons of data. But at the time, you couldn't store past like a month's worth of log files, and customer information was like limited to the bare minimum you need to know about them, right?
Mhm.
Because you couldn't store that much. And so there became a point in time where it just became cheap to store as much as you could, and then you could analyze all of it.
Mm.
And I guess that was like the beginning of my journey with like business intelligence. Although that was in my title, nobody called me like that. It was like the head of web development. But all the people in the company knew if they wanted data about their departments, they come to me. They
Yeah.
wanted to know, say I managed the CRM in the company, the customer relationship management system, and so they wanted to know details about the CRM they couldn't get from the CRM system itself. They would come to me. They want to see the connection between the CRM and all the different marketing channels. They would come to me because I had all the connections between
Mm.
all the different sources. So I
Mhm.
would generate all these reports. Um, and That's when I hadn't quite realized then that my journey would take me to data science. I,
Mhm.
I still saw myself fundamentally as a builder of
Okay.
things. You know, I didn't see myself as, I obviously like data was at the core of everything, but I didn't think of analytics as something I did.
Mm.
Um, Strangely, although it at some points it would occupy like a third of my time or more, but it wasn't until later I started to ponder on that, realize there were people actually doing that job. you know I
Mm.
think I start another job in 2013, I think, and I for the first time I met someone that was their job was business intelligence.
Mm.
Right? And it was weird because I was deriving more information that they were, and it's like, hey, I found this, and they were like, no, but this and this other thing. But I had more reasons to validate my hypothesis than they did. But
Mm.
the thing is, I didn't have that background. I couldn't call myself, oh, I'm a business intelligence guy.
Mm.
So um, I didn't know it was viable for me to move into that career till like more and more it became more like programming became part of it.
Mm.
It always was in some circles, but for people that were starting to use Tableau and systems like that in Excel, it didn't have to be all about programming.
Mhm.
And then later on, as kind of machine learning came into the fold as something accessible for everybody, then all of a sudden, like there's this need for people that can handle both worlds, right? Both the
Yeah.
ones with the graphical interfaces as well as, like ETL, as I had done, APIs and also a bunch of other stuff, including machine
Mm.
learning. So that's kind of how I got into that. I created a startup, and that startup required machine learning, and so that was my foray into machine learning back in 2015, 16.
Hmm. So you created a startup at the really beginning of machine learning and these concepts, right? About this period when you create your startup, because before you mentioned like how there was at the really beginning there was really poor data, and then like having data were becoming cheaper and cheaper. You mentioned tools like Excel, data visualization, Tableau, and then you mentioned like you start working with APIs, you start working with ETLs, moving data. So at what point did you decide that you wanted to go on your own and you wanted to do machine learning applied to, I would assume, business?
Oh, well, once I applied it to my startup, my plan was just to work on the startup,
Okay. Okay.
but the startup ran out of funds, and so then I had to come up with a new plan.
Okay.
And so that new plan said, okay, well, I'm going to be serious about this, and I'm going to transition into this field. So a
Mm,
good signal for that, not only for others but also to myself, to gain
mhm,
confidence in it, was to go and
mhm,
get a degree. So I got a master's in data science, and after that, I I started to um, you know seek jobs with that specific title,
mhm,
because before that it was kind of unclear to people
mhm,
looking for jobs. I've done the work for many years. I had done ETL since, I don't know, 2004, 2005, and APIs around even before that. But
mhm,
uh, and it just wasn't clear, that was what you did, right?
mhm,
Because
mhm,
so I kind of had to have that clear signal in my resume that that's not what I did. So and also, I learned quite a bit in the masters. It wasn't just about getting a title. I did get a better, statistical foundation,
mm,
and I learned some new methods. I learned more about computer vision,
mm,
and so I really enjoyed that.
hmm. So you went for a master to have like improve your fundamentals and maybe have like more ideas about where like what kind of technique you can apply. And you mentioned before that you are yourself a huge learner and you've been learning through your entire journey. You teach a lot, you mentor a lot. Uh, would you have like tips for the people who are listening? Would you have some tips independently of where they are at their in their career, like some key lessons, not necessarily about technology but about the learning process of things? Would you have some tips to share on this topic?
Yeah. Well, whatever you want to learn, I see it as the biggest hack to be play. Um, and play is about excitement. It's not like you're trying to build something. It's just you're just interested in a particular tool, a particular kind of problem, an industry, and you just do something involving that. So you keep that excitement going. So it's like a very simple, I guess, piece of advice. I think a lot of people go for, like, I want to learn machine learning, so I'm gonna download the most common data sets people use for that, and they're not even interested in the problem, right? And so they don't learn it as well. But if they've already worked in an industry and they're excited about that industry, they should just, or maybe it's not an industry they've worked in, but they're just interested and curious about it, they should use that. I mean, for instance, if your thing is music and you love, like, you want to, you love all the statistics behind all the artists, or maybe your thing is sports, download a data set about that. Examine it, maybe find a problem you want to solve through machine learning, and then go through that, instead of kind of going through all these recipes that already exist online involving the most boring data sets ever, you know and work on that. I think it's just a question of first finding what you're passionate about and working on that, and then seeing everything else as a tool to that. But also, don't try to make it all about the tool, because it just might be the wrong tool for the job. Not every data set is meant to be, you know, used in machine learning. Some are more like, okay, a project for Tableau or something else. They're more like explorative.
Hmm.
So
Yeah. That's an interesting question. When is the difference between? I mean, the answer shouldn't be like when is the difference? Like, at what point do you tell to yourself, okay, I'm going to go more for a analysis of the data. I'm going to import it in Tableau, in Power BI, or I'm going to do things with the data. I could assume that you can do first the visualization and then go further with models, but how do you approach like problem solving in the industry? How do you approach it?
Well, it starts with a question, but for every question, you should ask several questions back. So it's not like sometimes people will tell you, "I want to solve this problem," and they're already telling you the solution is machine learning. I want you to solve this problem, and you're like, "Hold on, wait." Let me first examine the data and see if that's
Mm,
even a possibility.
mm-hmm,
And even if it's a false possibility, does that solve your problem? So you
mm,
kind of have to push back and ask them, what is the problem precisely?
mm,
Because they might just give you part of it. They might just give their perspective of what the problem is.
mm,
And the problem is really not something that should be solved through machine learning. Maybe you realize through the data that it's just the it's so clear, the decision boundary is so clear, it doesn't even need machine learning. Maybe you
mm,
realize, or you could just draw a line through a threshold, and it's just a simple if that will solve all the problems. So what's the point of machine learning?
mm,
So um, I think you have to examine it from a point of view of skepticism. It's not like
mm-hmm,
especially if it's coming from the business, because the business have a very good perspective of what they need, but at the same time, the idea of AI and machine learning has been hyped. So
mm,
it's seen as like the universal like hammer that can solve everything,
mm-hmm,
and that's not always the case. And even if it could solve a lot of things, it might be overkill. So
mm,
um, yeah, I don't think there's like this rule where I can tell you like this is when and this is not. I mean, I think machine learning is best for very complex cases that can't be easily explained by a human, that a human has challenges with. Like one of the questions I like to ask in my industry in agriculture is, how good are farmers at X problem you're describing at me? How good are them at estimating yield? How good are them on anticipating what kind of diseases they'll get? Because based on that, you understand, if it's worth it, what kind of metrics you should use, and what how to evaluate these metrics. You
mm,
know, so I think it ultimately the value of machine learning is to be able to um, assist human decision making, or in some cases supplant it.
mm-hmm.
So if it can't even do that, then what's the point?
Yeah. Yes. And now that we're discussing about your industry and like how to approach a machine learning problem and how we need to have this skepticism towards the business coming and having a need, could you maybe share with us an example of a time where you had to solve a problem through machine learning and you really enjoyed the solution and the process? Could you have an experience to share and like the approach of the problem solving?
Hmm. Yeah, like many years ago, I was working in 3D printer manufacturer for a 3D printer manufacturer.
Okay.
So one of the problems they had that was of very high value for them to fix was printers getting returned for defects.
Okay.
So it's kind of costly when, not only because of the shipping and all that, sending a printer back, but the other thing that's costly is, potential of losing the customer,
Yeah.
potential of the customer not buying as much supplies because they stopped using the printer. So from that standpoint, I forget what it was, but it did amount to potential losses of thousands of dollars for customers,
Hmm.
especially it's highly weighted because some of them are industrial customers that are using the printer all every day, right?
Mm-hmm.
A lot. So um, the problem was I was trying to solve was anticipate when a printer would fail
Okay.
based on all the data that the printer would generate. So whenever a printer would print, it would generate like temperature, you know, what amount of movement the motors are doing and how they're doing it. You know, like
Mm-hmm.
very specific things, as
Mm-hmm.
well as like very uh, kind of summary statistics on what was being printed. You know,
Mm.
what kind of resolution was involved. You know, uh, what size of the model, what is the complexity, the amount of vertices the model has, things like that.
Yeah.
So um, this problem involved figuring out basically what is the best way to kind of break it down. And a
Yes.
lot of people would have said, well, the best way is to take a single model, a multi-classification model, and output what kind of failure we'll have. Or maybe forget about what kind of failure, just whether it's going to fail or not
Yeah.
within the next few prints, right?
Okay. Mm-hmm.
And so the first thing I figure out um, what was the best, what are the best thresholds? That's
Yeah.
often one of the best questions to ask. You know, when you're talking about things like surviving something, or you want to see the point where it becomes eminent, which might not be right away. You want to say, okay, well, is it going to be in so many days, or is it going to be in so many prints? How should I measure this?
Hmm.
So I found the best threshold for that. I forget what it was, but I found it, and it wasn't the same for every kind of failure.
Okay.
So that's what led me to think, well, I shouldn't deal at this as a single problem, because their behavior is always different. Their features are different. Their their thresholds are different, you know,
Hmm.
and so I shouldn't deal with them in a similar fashion.
Because
So
just a quick question. Like for example, you had like different printer models that were having different types of error. Is that correct? Or was
not
it like
not only
one?
that, that's true. That's a good component. Different printer models with
Okay.
different software.
Okay.
That was another. In some of the failures, software was a big indicative. You know,
Okay.
uh, because there was one particular software build that was more prone to error
Hmm.
for one of the failures, um, and in some cases they were almost always the same model of printers, so it wasn't so much of a problem. In the newer model, there wasn't enough data for it to actually kind of come up with a better um, a good way of kind of predicting it, because there was not enough data for it yet. But
Hmm.
at that point, I figured that the best way of doing it was just having separate models, one per failure type. There was a kind of failure was an optic failure, and
Hmm.
that has to do with the laser of the printer kind of wearing out over time. And that was
Hmm.
one of the easiest ones to rule out.
Okay.
So, and then there were other kinds of failures. I think there were maybe 8 or 9.
Okay.
So, what I did was I said, okay, I'm going to train different models. Um, at first, it didn't matter what kind of model it was. I tried pretty much everything, from naive Bayes to neural
Yeah.
networks and XGBoost and everything.
Mm-hmm.
So it didn't matter. The point is, it was the best at discriminating the failure,
Okay.
right? And so then I would do them in cascade. So some of them were similar, but I knew if it was an optic failure, it could not possibly be a different kind of failure. So I first ruled that one out, and I ruled that out. Then it would go on to the next model and the next model and next model. So it ended up being like a cascade of different
Hmm.
models, one
Mm-hmm.
discriminating under another, and then I had a last kind of catch-all one that would determine just if it would fail in general. What was
Mm.
the probability? And that one would just, I don't know. There's like an unknown failure that might happen in the next few days, and that's
Okay.
so I had like a
Okay.
catch-all,
Okay.
and that was it.
Oh. And is this catch-all, is this like an ensemble learning? Like, do you glue the models together, or do you just take the outputs of each model? And if there is one that have a high probability based on the metrics that you used to detect a failure, then the overall logic would say, okay, it's gonna fail. It might gonna fail.
Yeah, no, this wasn't an ensemble. In that case, it's more like a one over, I think it's one over rest kind of scenario.
Okay.
But it wasn't, it was just programmatically, it wasn't formalized in any kind of structure like that. It was just
Okay.
a bunch of if statements
Okay.
in an API. Um,
Okay.
yeah, beyond that, I didn't do much more for that project to formalize it. But yeah, I did think of doing something like an ensemble,
Hmm.
but at the time, I think I I I spent so much time getting to design the solution. By the time I came
Mm-hmm.
to the modeling and everything, it just happened very quickly in
Mm-hmm.
a couple of weeks, and then it had to be ready.
I
um,
see. I see.
yeah,
Awesome. That's a very insightful experience. I myself am at the beginning of a career in the field, and hearing you approaching problems gives ideas for coming solutions to find. So
yeah.
thanks for sharing.
Uh,
So that's very interesting. So we mentioned how you came into data science. We went a bit through an example. I would like to ask you about the book, the upcoming book, and democratizing AI. But just before that, I want to ask you about the future of AI and the future. More specifically, AI means a lot of things nowadays, like the future of machine learning and the jobs, the data science jobs, head data scientist jobs, uh, tasks to be tackled in the future. Could you give us a bit of your vision of the future of artificial intelligence, machine learning, data science, and the field?
well, I think right now everything is very correlation based. I mean, and that's both been an asset because that's like the simplest thing we can find in the data without getting too involved,
Mm.
right? At the same time, it's also a liability because that's not really at the core of what we're trying to find out with these. The questions we generally ask in machine learning are ones that we want to see a causal connection with. So I do think in the future of AI, there's definitely more causal component.
Did you say
There's a
causal
growing
causal
causal.
component?
Yeah.
Can you tell me what is causal component?
Well, that's basically. I'm just touching on the possibility of causal machine learning taking over the field of AI.
Okay.
It's a growing field. There's a lot of more models coming up,
Okay.
but it requires a lot more engagement from the practitioner,
Okay.
from a domain expertise point of view. Because right now the way machine learning is done is very model centric, and
Oh yeah.
it's definitely like a question of, oh, let's just throw a bunch of features here and see what sticks, like taking all this
Yes.
spaghetti and just throwing at the wall and see what sticks.
Mm-hmm.
And so far it works, but it doesn't work to the extent that we want it to. It makes a lot of spurious kind of connections, like um, even things like, okay, a classic case of computer vision is, okay, let's make a, a, a classifier between a dog and a wolf, right? What's
Mm.
And so we throw all these images from online from dogs and wolves, and then we realize it works fairly well. But why does it work well? Once you look into it, it's taking cues from the environment. It's realize it's saying, okay, a wolf is a wolf because it's near the snow.
mm,
It's not a wolf for any other reason than that.
mm, mhm,
Then we for human, those things are kind of obvious. So how can we make machine learning work in the same way,
mm,
where it's making these very subtle connections between different things that are encoded in the data.
mm,
And so it took humans a lot of time to develop that intuition.
mm,
So how do we bake it into the models? All these connections. They're it usually requires a lot of domain expertise. Even if
mm,
we're talking about tabular data sets and we're saying, okay, well, we have this financial firm and they have this new algorithm to kind of, you know, uh, decide if to trade, or not to trade this
mhm,
particular stock today. Uh, a domain expert would say, well, we can't because the market conditions are like this. And there'll be this whole like really complicated causal graph between all the different variables. This one affects this one affects this one. This, if you throw that at any machine learning model today, all that is lost. These connections are lost. They all kind of seem to correlate with each other. So
mm,
the model is not really good at being able to determine what impacts what. They all
mm,
kind of impact each other at varying degrees, but it's not able to make that connection that one particularly goes in one direction or another. One is a cause, another one is effect.
mm,
So if we bake that into the models, we come up with smarter models. So I'm a even in machine learning, I'm a huge proponent of putting guardrails. So something I describe in my book is called monotonic constraints,
mhm,
and what it is you have variable connections. You have um, a target and a predictor, and the predictor is supposed to relate to that target in a specific way. Like for instance, in my field in agriculture, you know that you know more sun leads to higher growth of the plants.
yeah,
So the more sunlight the plants go, the more they grow. Or the more days that go by, the more the plant is going to grow. It's not going to decrease in size,
mm,
right? So uh, one way to bake that connection into the model is to say, well, there is a monotonic relationship between them. You know, as the days go by or the sunlight increases, the plant must grow
mm,
higher and higher. So
mm,
um, it's an upward trajectory, if you
mm,
will. And so there's no way it goes in the opposite direction at any point. And
mhm,
and there's a lot of relationships like that you can put guardrails with.
mm,
In the same way, I think you can do the same with causal relationships. Is a kind of guardrail in a way because it's making sure that the correlation that the model is uh, kind of perceiving in the data is only going in one direction. So that's one way of seeing it.
okay, okay, that's very
So
interesting.
that's one trend I think that's gonna come out. But there's a bunch of other ones. Like
Okay,
we were talking earlier about what happens when you have to build a model that deals with different scenarios. Like
yes,
like with the printer scenario,
yeah,
uh, you have all these different features, but they lead to different outcomes
mm,
depending on a single variable. What variables that is what kind of failure you're expecting.
yes,
So the outcome and the things that lead to it are different. Um, the way models are built today, they're very dense. So you're expecting you're expecting all features to always play, always have an impact. Even if it's in a tiny way, they're always having an impact, or they're allowed to have an impact. So uh, they're breaking out of that dense mentality where everything's operating at every single time will allow us to be more creative. And there's
mm,
some work at Google happening right now
mhm,
involving that kind of model. I forget what they called it, but I'm excited about it because it's precisely, it's ridiculous to think like even any brain is not operating at full cylinders. Like at any given time, only certain parts of your brain are firing neurons.
Yes.
So we have to build models with that kind of thinking, that we have parts that fire at certain times and others that don't.
Mm,
Um, and so that's another trend. There's also going to be a lot going on with hopefully on the with blockchain. I think there's going to be more integrations having to do
mm,
with data provenance, tracking, kind of creating a trail of what goes on in the modeling process, so we can better track them.
mm,
um, yeah, I mean, off the top of my head, I can't think. There's just so many different little micro trends, not only in the modeling space, but also in the data engineering space, in the MLOps space, and those will impact what's going on in the modeling space.
mm. Okay. Okay, that's very interesting. Um, I want to ask you about a specific topic that I think is very over over discussed at the moment, but I will keep
Hmm.
the
Hmm.
suspense and I will ask you something else just before. Um, what do you think about quantum computing uh,
Oh.
and the impact in the field?
I honestly think it's a bit overhyped. I
Okay.
think quantum, like general AI, is you know quite a bit away. You
Mm,
know, I don't think it's going to have the immediate impact in the field.
okay.
There is a need, because if you see the trajectory of Moore's law, we're soon coming to a slowdown. We won't be able to go beyond, physically we can't go beyond soon enough than the amount of transistors we're trying to pack in with at least silicon.
Yeah.
So uh, we have a need to actually come up with something to uh, keep the innovation going with electronics, and we're not going to get that through the means we have right now. And
Mm,
I've seen a lot of other alternatives that are growing. One of them is using analog computing.
okay.
Um, Analog right now, like for, I don't know, 7 decades at least, the paradigm we is everything through digital, so it's all ones and zeros. But when you think about it, AI, like everything, is the kind of mathematics that are required in AI is all with continuous floating point numbers,
Mm,
like large matrices of them.
mm-hmm.
So it doesn't make sense. It's counterintuitive to continue using digital.
Mm,
A very promising startup. I wrote about this in LinkedIn last year, from Texas. Is It has created this analog chip, and it works it the same way. It doesn't need anything special to work, in the sense that it is electricity can be, designed to work. I mean, by default, it's already working with, you have a continuous amount of current, and you can use the way the current works. I'm not an electrician, but I'm trying to explain this the way
yeah.
I understand it,
Uh-huh.
which is you can use the current to kind of do all these multiplications,
Mm,
additions, multiplications, with the amount of current that's happening in the chip.
mm,
So you can generate, using this, you can generate you can do all the multiplications on a very fine scale, where you're doing like vector operations en
mm-hmm.
masse, and
Okay.
without the need of all the current that's currently being used
Mm,
for the digital
okay.
analogous to that. So
Mm,
that's one of the benefits. The other one is just far more efficient, because it's not counting with two fingers, it's counting with infinite amount of fingers.
mm,
So it's just far more efficient. So I think
Okay.
it's gonna that's one direction I could take. Another one is through neuromorphic computing, or even using biology
Yeah.
instead of material science. So like there's been a lot of studies that you can store data in DNA,
Mm.
or you can use mushrooms for certain things. I forget what they can be used for, but it's very interesting
Yeah.
where this might go,
Okay.
if we kind of just kind of get out of this idea that everything has to be digital and is silicon.
Yeah. Yeah. I understand. Um, I still need to understand well the difference between analog and quantum computing, because both are like not zeros and one anymore. But I will research onto it. I
Oh
might do
yeah,
some
yeah.
flashcards that I will post on LinkedIn about the difference and trying to explain this topic better to the Let's Talk AI community. Awesome. So thanks a lot for sharing the things. I will end the suspense. Maybe you forget, but I will end the suspense about my other question, which is generative AI and the famous ChatGPT.
Hmm.
I feel like we I needed to ask you about generative AI, and it is interesting because you mentioned about models that are not like going to do only an output of a classification of very specific things. How do you see AI, generative AI, being used in approaching projects that you might face on a daily basis? Do you think that generative AI can really enhance some of the points you were mentioning before, or what's your state on the topic?
Mm. Well, generative I mean, like other kinds of AI, is dependent on the data you train it with.
Mm,
And so my concern with it is the same it is with other AI, except it's harder to detect when it, the biases. It's very ad hoc how you figure these things out. You
yeah,
know, for instance, how can you tell if AI is sexist, if it's always, if you ask it to kind of generate female characters, if they're always going to be sexualized?
yeah,
How can you tell that, objectively? And more importantly, how can you counter that? And it all boils down to the way you treat the data. So it takes, right now, a lot of that grunt work of labeling data and doing that is done by either the people that put it online to begin with, possibly many years ago, just random people, or kind of mechanical Turk workers in third world countries.
mm,
So we have to be more careful about these things,
yeah,
because and it's really tricky, because what kind of criteria you're using to either put something in a model or not, and especially uh, what scale do you need to make a good model? Because we're using millions of images, or millions of pieces of text, and it's not necessarily going through human eyes before it's doing that, before it's
mm,
using this information. So
mm,
uh, how do we make the process fit our needs right now and in the future? And what kind of needs are those? Because that's another thing. What are these models for? If they're general purpose could be anything. And we've seen
mm,
it before with chat gpt, like people were using it to come up with recipes to build bombs and things like that. And of course you could say, well, people were doing that already with Google, but the difference is Google is more of a controlled environment.
mm,
Like it, over the years they figured out the best way of kind of protecting the general public,
mm,
whereas ChatGPT was just I'm not saying some effort wasn't put into it, but not nearly as much effort. It's impossible as Google to kind of put the guardrails necessary to cover every single bad use case you could think of.
yes. Mm. And as an author, do you think that generative AI will make everyone write books, or like how do you approach as an author? And I'm going to ask you about your upcoming book right after that, but how do you approach generative AI to like maybe accelerate the process of writing or improving the writing of one, or like how do you see this?
I don't think it's creatively. I don't think it's stifling at all to have extra tools. And I don't believe that it's gonna necessarily disrupt the space where it just becomes more difficult uh, to be a writer or be a creative person. I
Mm,
think it's just it does up the game in the sense that like in a time where anybody can become a mediocre artist or writer, and I don't mean that disparagingly, but like it's these tools aren't perfect. They're still making all kinds of mistakes because they're based on all pretty much everything out there. So they're like an average of that. So it's still going to be competitive for someone to rise to the top. For someone, it's like, yeah, like let's take it for instance, autotune. So people can sing with near perfect pitch, even though it sounds kind of robotic, with
mm-hmm,
autotune.
mm-hmm,
So that has lowered the barrier to entry to become a singer. But people can still tell what are the best singers in the world at the moment. They can still tell, oh, that person really has talent, regardless of that.
mm,
And a way, it's also enriched music by creating a style. Some people don't like it, but there's this auto tune style. Some people appreciate it. So it's created a like a different kind of genre, and just or not just one genre, but a series of subgenres based on that.
mm,
So I'd say it's it's not necessarily something that's meant to displace existing expression, creative expression, but enhance it, enrich it,
mm,
and it can be a tool even to help people that are already professional at it. You
mm,
know,
yeah,
so even artists that are good singers still use all kinds of tools to kind of enhance their already great talents.
mm,
And I don't see that as necessarily a bad thing. There's of course purists out there that say, oh, well, people shouldn't be doing that anymore because it's kind of the beauty is in the imperfection.
mm,
So that's more like a philosophical question.
yes,
If And I think that's actually one of the things that it's always easy to pick up what is fake and what is real based on either the lack of imperfections or very odd imperfections based on the training data, like how
mm,
you'll know that stable diffusion or dolly is always bad at making human hands, right?
yeah.
um, but at the same time, like the faces tend to be slightly more symmetrical than in real life and things like that.
Mm. Okay, that's very interesting. Thanks for sharing. I'm going to ask you about the book. So, from my understanding, your upcoming book, you will remind me when it's going out, but it's about democratizing AI. So, I would like to ask you about yeah, the different topics you approach in the books, a bit why, and like what are some of the key messages that should be in this book.
Well, the idea behind it is anybody can play with AI these days, and it's also an opportunity to explain some of the basic foundations of what AI is and what AI
Mm,
is and how it works, kind of dispelling some of the myths behind it.
yeah.
Um, what I realized is that there's a lot of books on AI, and they either go in one or two camps. There's like the hands-on books for practitioners, that work in the field or want to work in the field. And then there's
Mm,
the high level kind of books that
mm,
either go in one or two camps, either the ones that kind of hype the goodness of AI or, AI on the worst case scenarios, right? So,
mm-hmm.
and there's nothing in the middle for people that just want some of the hands-on stuff, but they're by no means, they're not necessarily experts.
Yeah.
They don't want to become experts. They just want to play with it. Um, or there's also the people, um, another potential audience for my book would be those that are already like you and I in the field, but want to take a more playful approach to it.
Okay.
So the book is called DIY AI, Do It Yourself AI, and it covers a lot of topics that are not covered a lot in the academic books, nor of course in the ones that are like less technical, like for instance,
Okay.
facial recognition, sound recognition,
Mm.
pose detection, and a bunch of different generative methods. You know,
Okay.
how do you create your own chatbot? You know, that sounds like, I don't know, your it could be you or your dead grandma, or whoever you want,
Mm.
or an author, a famous author. And then there's an entire chapter devoted to generative art. You know, and the idea behind that chapter is to teach you how to make a virtual museum. So it uses augmented reality. There's so many different projects in this book that are uh, more about play than about build. You know, sure, they tell you a recipe, but there's variations you can do on your own. And the idea is to kind of tell people, just, okay, you can follow the steps, you can deviate from them, but make sure you play. Make sure you do something that you're passionate about with it.
Mm-hmm. Mm-hmm.
So this is just a tool.
Mm.
So play with the tool. And so
Yeah.
I'm interested to see what people come up with.
Mm.
What do they use the facial recognition for? What do they do in their virtual museum,
Mm.
and so on? It's because one thing that's happened over the last years is
Mm-hmm.
that it's become um, passively, kind of passively. I wouldn't say like people don't know about it, but it's become more accessible. But
Yeah.
even though it's become more accessible, at the same time, um, there's still a bunch of myths. There's still a lot of buzz. It's not just a tool, which is the way people should see it. Um, I think I kind of connected to the way things were when the internet was brand new.
Mm-hmm.
You know, there were people that were kind of scared of it. They were like, even scared of writing an email. Am I
Mm-hmm.
doing it right? Like there was some kind of grave consequence to doing it wrong. And I think we need to break that, so that people that are interested in it and are sufficiently technically capable of doing it can do it. You
Mm.
know,
Yes.
eventually, I think just like it happened with the internet, um, everybody and your grandmother will have AI models the same way everybody has a website. uh,
I love my grandmother, but I doubt she will have soon because she's trying still to fight with paint to do a
uh,
few things. So,
yeah,
but this is I totally understand the message, and
yeah.
mommy, if you're listening this, and she's struggling also with English, so slightly probably I will help you implement a model I don't know, for recipe. I'm sure she will love that. That's awesome. That's
Yeah.
super cool. And when is this book coming out?
November.
November.
Yeah.
Okay, so hang tight and wait until November. That's perfect. So I think we're at the end of the episodes. I would have so many more questions, but maybe for an episode two, who knows? Let us know what you think of the episode in the comments, and I still have three more questions. The three finish line question, let's say. So
Hmm.
the first one should be, if anyone is in the field or anyone who are inspired to what you said, or maybe want to ask you a question or follow your content, your books, your posts on LinkedIn, where people could reach out to you or know more about you.
Well, there's only one of me. So if you search me in Google, you'll certainly find my stuff. You'll find my LinkedIn page. Also, if you search for me in either in Google or LinkedIn, you'll still find my LinkedIn page. Twitter, same deal. Um, I think those are the social media sites I'm more connected with. I
Mm-hmm.
also have my own. website. It's surge.ai. You can find me there as well.
Okay. Hmm. You have your own domain, search.ai.
Yeah.
That's a oh. I couldn't find thomas.ai, but that's awesome. All right, so I will put all the links in the description. The second question is, um, could you um, could you do you have like any tips about your learning journey, like things that really helped you, even though we kind of discussed it a bit earlier? Do you
Yeah.
have like a few more tips for people who are learning, who want to grow their career, make decisions?
Well, I think that the best thing is to kind of follow your passions, as I said earlier, and let those lead you to the best tools to kind of do whatever it is you want to do with that. But don't start with answers. Lead with
Mm,
questions. Instead,
mm,
it's better to have questions than assume you have the right answers.
mm,
And then connect with people in the field and ask them those questions. They might be able
mm,
to guide you. Don't expect them to tell you, okay, one, two, three, you have to do that.
yeah.
Just point
Mm,
you in the right direction.
mm,
I think
mm,
that's more important than anything.
mm.
Um,
And this
eh,
is this is funny you mentioned
Finding a
that, because
community. Yeah,
finding a community, yes.
yeah.
All right. This is funny. This is funny that you mentioned this approach, because not later than today, I was struggling for like an hour or so on an NLP task that I want to realize,
Hmm.
and I know this very NLP expert, Abdullah Trésor, and
Hmm.
so I just reached out to him and I told him, all right, this is what I'm trying to do, and I've tried this and that. How would you approach this problem? Like, just like give me some insights. And he told me, all right, you need to consider this and that. So maybe go in that direction. And I was super happy, because after struggling myself with a few things, I had
Hmm.
kind of a guidance of things that I've saw. Like I literally saw those libraries and tried to do things with it, but I came back onto it and took more time to study the fundamentals behind and how it works, and it really saves me time. So like the balance between like trying fun things, as you mentioned, and like reaching out to someone, a community, or someone that knows the direction, not maybe not the answer, but the direction to take. That's
Absolutely.
awesome. Well, thanks a lot, Serge. My last question, my favorite one. Do you have a message for the Let's Talk AI community? It can be both professional, personal, a mix, a balance of, like, just do you have a message that define you or that you want to share?
Mm. That's a good one. Um, I I'd say like just keep on learning. It's all about learning. We're all in this journey together. I think nobody can claim to be an expert. Um, I mean, I think a field has to be more or less, maybe not final, but almost to be able to say, "Oh, I'm an expert in this,"
Mm,
and or and that's not the case with AI.
mm. All right. That's cool. I will note this to myself and put it on my wall and read it every morning. I want to thank you so much, Serge, for coming on the
Sure.
podcast. It was such a pleasure to having you. I wish you all the best with everything. Look out for the book in November, and I wish you
Mhm.
to have a wonderful day.
You too. Thank you.
Bye.
Bye.